Okay guys, welcome to this A2 level pure mathematics video, okay, looking at differentiation involving the quotient rule. So this is aimed at predominantly year 13 level students, okay, in the UK, so in England, okay, but it's also appropriate, yeah, as well as, yeah, for year 12s as well, okay, if you're learning, yeah, differentiation involving the quotient rule. Okay, so this is question number one, guys. I've got y is equal to e to the 2x all over x squared plus 2. Find dy by dx. Okay, so first of all, yeah, label the numerator as u. So u is equal to e to the 2x. And v is our denominator, which is going to be x squared plus 2. Okay, now differentiating, okay, each function separately, okay, du by dx, so du should be a u there, yeah, just to make it clear, not a v, sorry, it's a u, so du by dx, well, the 2 comes down here as a multiplier, so yeah, it goes to 2e to the 2x, okay, so differentiating 2x, and it comes down, yeah, as a multiplier. So differentiating here, 2x is just 2, so that comes down here as a multiplier, okay, for that, okay, dv by dx, so differentiating x squared, the power comes down, okay, as a multiplier, and then the power comes down by 1, so 2 goes here, so 2 goes here, and then the power reduces by 1 here, which is just x to the 1, which is just x, okay, and then differentiating the number 2, a constant, just goes to 0, okay. So yeah, plus 2 goes to 0, okay, when you differentiate it. Okay, so the formula for dy by dx, okay, of u over v, okay, so when you have a fraction here, that's what I call a quotient. A quotient here means that I've got a fraction here, like a division. Okay, so u over v, it looks like a v there, guys, I apologize. Sorry, yeah, about the actual lack of spacing here. So the formula is as follows. It's v du dx. Okay, so order here, yeah, actually matters. So v du dx subtract u dv dx all over v squared. Okay, now I do believe actually, unless I'm mistaken here, I do believe actually they obviously give you this here in the actual formula booklet. Okay, but if they don't, then obviously, yeah, please do obviously actually learn it here. But as far as I'm aware, from memory, this is given here as part of, yeah, like the formulas, yeah, for differentiation, okay, within, yeah, the functions. Okay, yeah, so it's v du dx subtract u dv dx all over v squared. Okay, so using this formula here, so dy by dx, okay, so taking our time here, so being very careful, okay, and again, sorry, yeah, about like switching my work here. So v du dx should be 2e to the 2x, okay, and then in brackets x squared plus 2. Okay, let's just obviously delete that here, so let's delete that in little lines. Okay, for that, subtract u dv dx, so that times that, so subtract 2x e to the 2x, okay, all over v squared, so all divided by x squared plus 2 all squared. Okay, now I can leave it like that, okay, that would obviously suffice, but yeah, I'll just obviously tidy up the actual numerator here, but I'm not gonna bother, yeah, ever like explaining, yeah, the actual denominator here, because then it becomes a bit messy, okay, but you can, yeah, obviously expand and simplify, yeah, top and bottom if you want to, but I discourage you obviously, yeah, because in your exam, yeah, you are on like a time limit, like even if it's like a 2 hour paper, actually, obviously, yeah, it still obviously takes a bit of time to obviously expand and simplify all that, okay, but where possible, simplify, yeah, the numerator, but leave, yeah, the denominator, yeah, actually factorized, okay, yeah, or within its power. Okay, so expanding the top, actually, I'm going to get as follows. So expand this here, so I'll get 2x squared e to the 2x, so I'll get 2x squared, so 2x squared, okay, e to the 2x, okay, so that's, yeah, sorry, I should delete that shit there, and then I'm going to have plus, and then I'm going to have, I think, 4 lots of, so 4 lots of e to the 2x, yeah, when I expand that single bracket here, sorry that I should delete there, but hopefully you can remember that, okay, yeah, okay, it's v du dx here, so it's this times this plus this, yeah, the same number times 2, okay, now I can factorize the top, okay, so I can take out 2e to the 2x as like a common factor, okay, And this other bracket, I'm going to have x squared plus 2 subtract x, okay, for that, okay, all over x squared plus 2 all squared, okay. And that, yeah, is as far as it goes here when you obviously simplify it. Okay, I can obviously factorize this here, but I'm not actually going to bother. But yeah, that is, yeah, like obviously simplifying, yeah, obviously a bit further. Okay, that's important because a part B might say that, yeah, like find like a stationary point, okay, or like a turning point, yeah. So that's when you set the derivative equal to 0. Okay, so yeah, you will have like a quadratic there. So you have x squared, yeah, minus x plus 2, which I don't think actually factorizes this year, but yeah, essentially you may or may not have your like turning points here depending on the question. Okay, but yeah, sorry for taking a while actually on that. Okay, second question, y is equal to sine 2x all over x plus 3. Again, label, okay, so find dy by dx. So y is equal to sine 2x, okay, and v is equal to x plus 3 all to the power of a half here. So square root means power of a half. So x plus 3 to the power of a half. Okay, sorry, it should be u is equal to that, not y, sorry. So u is equal to sine 2x. Okay, so u is always equal to your numerator of your fraction, and v is always equal to your denominator to make it a bit easier. So I'll put dy by dx there again. So du by dx. So differentiating sine 2x using, yeah, the chain rule. So differentiate 2x goes to 2, so that comes out as a multiplier. Sine goes to cos, so yeah, it's just 2 lots of cos 2x. And again, yeah, they are ones, yeah, that you'll have to remember, yeah, for your exam. Okay, yeah, so make sure that you practice, yeah, differentiation, yeah, of your trig functions. Okay, again, yeah, I'm treating this here like a revision video here, so bear with me, guys. Yeah, okay. So a revision video, yeah, assumes that, yeah, a lot of this here you obviously covered it here, but again, yeah, feel free to obviously pause here and obviously go back where possible. dv by dx, so the half comes down as a multiplier, okay, half brackets x plus 3, okay, to the power of minus a half, okay, yeah, because the power comes down by 1, okay, and the power reduces by 1, okay, times the derivative of this, which is going to be 1, okay, so yeah, it doesn't actually change my answer. Okay, so dy by dx, yeah, so this one here is a bit more fiddlier, a bit more trickier. Okay, so it's v du dx, so yeah, it's going to be 2 cos 2x, and then yeah, I'll put like a little bracket, open bracket, and then it's going to be x plus 3 to the power of a half. Again, I might not have much space here. I apologize. I'll try and put like a little square there. Yeah, no, actually box it off. Subtract u dv dx. So that times that. So I'm going to have, yeah, a half sine 2x. And then open brackets, x plus 3 to the power of minus a half. Okay. All divided by, yeah, v squared. So if you square that, yeah, you would just get x plus 3 on the bottom. Okay. Now I can actually simplify that actually, but I'm not going to bother here because of like lack of spacing here. But I can factor out here an x plus 3 to the minus half on the top. Okay. Yeah, and simplify where possible. Okay, yeah, for that one. Okay, but sorry, yeah, in this video because of, yeah, like lack of space actually here, then I'm not gonna actually bother here. But you can obviously simplify the top there if you want to. Okay, the bottom, yeah, because if you remember, yeah, so if you square obviously v, okay, the square root, yeah, and the square obviously they cancel out, yeah, so hence why I'm just left with x plus 3 on the bottom, yeah. Obviously it's the power of 1, yeah, all of it to the power of 1. Okay, yeah, but I don't need to bother, yeah, with that power of 1 there. Okay, so that's my answer for that one. Okay, this next one, okay, so y is equal to natural log 2x, okay, or ln 2x, or ln 2x, all over x squared minus 4. Find dy by dx. So again, u is equal to natural log of 2x, okay. V is equal to x squared minus 4. Okay, sorry about my handwriting, guys. Hopefully you can forgive me. Okay. So du by dx, so differentiating, yeah, natural log x, okay, goes to, yeah, just